Hi everyone. Now this is quite an interesting video which talks about an interesting concept. And by the end of this video, you will be comfortable in understanding the anatomy of an AI agent. Now all of us very loosely talk about AI agents, agentic AI here and there. But when I ask someone that, hey, or when I ask junior AI engineers whom I am interviewing as to, hey, can you define what an AI agent is? Or rather, not just define, but can you give me an anatomy of an AI agent? Can you tell me which are the moving parts in an AI agent? And the answers that I end up getting are not absolutely right. Many a times they have an idea, but the answer that I end up getting is quite vague and not something that I expect. And that is when I understand that they haven't really studied the anatomy of an AI agent as to what constitutes in the making of an AI agent. Okay, and that is what we are going to discuss. It's a very simple concept, but it's very powerful to know. Okay, slowly and steadily we are moving into the core and the crux of developing and deploying highly potent agentic AI solutions on Windows Azure. But before that, we need to make certain basics clear, and that is typically what we're going to discuss here. Okay, now please try to understand. Okay, doesn't matter if you are working on one agent or if you're working on 10 agents or if you're working on a system of agents that are running on a dozen of cloud services. Okay, when it comes to an AI agent, an AI agent more or so is made of these 5 parts only, and these 5 parts are the model, which is the decision maker, the tools, the memory, the control loop, and the environment in which this world or environment in which the agents operate in. Okay, and that is what we're going to discuss. Okay, all right. Now let's imagine you work for an asset management firm. Okay, any asset management firm in the world you can take. Okay, let's say you're working for anything from JP Morgan to Morgan Stanley to Edelweiss, doesn't matter. You're working for an asset management firm. Okay, and you operate mutual funds. Okay, you work in mutual funds. Let's say this morning a regulator announced an investigation into a largely public listed company. Let's say this public listed company is BSE, and SEBI, which is a regulator, it has launched an investigation into a large corporate that is listed on Bombay Stock Exchange. Okay, and now let's say your head of risk management. Okay, let's say your head of risk management, let's say his name is Subhash. Okay, so Subhash comes to you and asks a simple question. Okay, Subhash says that which of the funds in our company are exposed to this company on which SEBI has launched investigation, how badly. Okay, and does anything in their recent filings suggest this was coming? Okay, so let's say we have gotten these questions. Okay, I'll write this question for you here. Which of our funds are exposed to this company, okay, on which the investigation right now is going on? How badly, okay, are we exposed to this particular company, and does anything in the recent filing suggests that this was coming, that this investigation was coming? Okay, now this question is deceptively hard. Okay, if you try to think of it, answering it means knowing what happened this morning, checking the current holdings of every fund, doing some arithmetic, reading through the filings, and putting together into something a human can act on. Okay, you cannot just have a simple database query and this database query is going to get you there. No, you have to work on n number of tasks, and after working on those n number of tasks, finally you can land on some output or some answer that a human can read and comprehend. Okay, And my friends, this is the perfect job for an agent. Okay, this is a perfect job for an agent, which is to think, act, observe, and work on all these particular tasks one by one. And that is what we're going to discuss here. Okay, so let's try to look at the anatomy of our AI agent. Okay, look at the first part. The first part talks about the model. The first anatomy part is what? It's model. Okay, now my friends, when it comes to model is nothing but it's the large language model, or any, not just large language model, it can be a small language model, it can be a medium language model. It is basically a language model that sits at the center. For example, let's say GPT-4 for that matter. Okay, whichever you have chosen. Its job is narrow and specific at each and every step, right? Look at the situation and decide what to do next. Should I look something up, or do I have enough to answer? Which fund should I check first, etc., etc. But I want you to be very clear about what the model cannot do. Okay, because the other four parts, okay, the other four parts, which is this and this, okay, when it comes to other four parts, okay, they exist entirely to compensate for the weakness. Okay, all right. So when it comes to my LLM doesn't know what happened this morning. Its knowledge stopped at some point in time in the past, right? It cannot do anything. All it does is it produces text, and text alone does not query your holdings and your database, right? And the moment a request finishes, it forgets everything, right? See, when it comes to my language model, right? My language model typically has two phases. One is pre-training and the other is fine-tuning. My language model is only exposed to the data, okay, or only has knowledge of that much data that was exposed to it in the pre-training phase. And after that, what my LLM has is something called as knowledge cutoff, which means it has knowledge which is only limited to the existing pre-training. But now what happened today morning, okay, how did the funds perform, etc., etc., that data or that knowledge is not available to my LLM, right? So a brilliant decision maker, in this case, what is my decision maker? My language model, right? So brilliant decision maker with no current information, no hands or no tools, no memory, right? So everything else we add today is a fix for one of these problems. Try to understand. As of now, your LLM has access to no tools. It has access to no memory, right? It has access to no current information, which means at the core what it is just an auto-regressive model, right? Which is, it's a next token predictor, that is it, right? But your LLM is the first and the most integral part of your AI agent. Okay, so first is model. Okay, next is what? Next is tools. My friends, what is tools? Tools is nothing but you can call tools as the hands and limbs of your AI agent. When my AI agent wants to perform any particular task, it performs that with the help of tools. For example, my AI agent, let's say it wants to search something on the web. So my agent can use a search tool, okay, let's say using Serper API key or using Exa or anything, and it can search for whatever information your AI agent wants to do, right? So tools are how the agent reaches out and performs a task in the real world. Now in our case for our mutual fund or whatever, for our risk agent, I would say, in this case, let's say we are running a mutual fund a company. So in our case, it's a risk agent. We might give it 4 tools. So our risk agent gets 4 tools. Okay, one is searching the news. So one tool searches the latest news. This news can be on X, it can be on some newspaper articles or news websites, etc., etc. The second tool is it will query the holdings database. So this is my holdings database which contains all my mutual fund records. I'm going to create one SQL tool which is going to take my language, take my human query or my input in natural language. It is going to convert that into a SQL script, and this SQL script is going to go and query the holdings database. Okay. Let's say the third tool. Okay, the third tool is going to retrieve the documents, okay, from archives. So my archives has some circulars. Let's say it has some circulars of Reserve Bank of India, State Bank of India, Prime Minister's Office, etc., etc. Okay, and let's say it also has one tool which is a simple calculator which is going to perform some complex calculations, and it is going to build my stock profile or my mutual funds profile. Okay, so my risk agent has access to 4 tools, which means at any given point in time my agent can perform 4 tasks with help of 4 tools. Okay, now here's the part that surprises people. A tool technically is just a function. It is just a simple Pythonic function, my friends. Okay, let me write it here. At the core, if you have to check, let me just, a tool is nothing but it's a simple Pythonic function. Okay, you can also write it as a decorator, and then you can define the tool. We'll see this during the course of our session. Okay, so as I said, the tool is nothing but it's a simple Pythonic function, okay, along with the description of what it should do. As simple as that. Yeah, now this description you can either write it in plain English or you can also hard code it in syntactical language in Python. Okay, description is the part that matters here, right? Because the model can't read your code, it only reads your description. My LLM can only read that particular description. So if you write that, hey, this particular tool, what this particular tool does, it gets the fund data. That is what this tool does. Okay. Now in this case, if I look at this one, this description is quite vague. If I just write this description for that matter, okay, let's say I'm building a tool, I am building a particular tool, and I end up writing this kind of vague description, gets fund data. Now this is, I mean, I'd say it is around 30 to 40% helpful, but it is quite vague in nature, right? And due to the vagueness of description, my model is only going to guess. And we know that if my model is just guessing, there is a very high probability that it is going to hallucinate the data. But in case if I write a very verbose, explicit description for my tool, okay, which is instead of just gets fund data, if I write it explicitly, if I say it returns the current holdings of a specific mutual fund, including the stock's name, ISIN number, and percentage weight. Now my model exactly knows when to reach for it and what will it get back. Okay, so please try to understand when it comes to defining the tool, defining the description is a very important part in your AI agent. So one, we have understood the model, right? Model is the first part of your agent. The second is tool. And when you're defining the tool, the description inside that tool becomes very important. As I said, this description, you can define it in plain English or you can also hard code it in Python. But trust me, this is an important engineering skill, okay? Because this is also many a times where your agents silently fail, my friends, okay? So if you're now, I hope you're enjoying the session. Yes. Anatomy of an AI agent, we have understood model, we have understood tools, and the third important part that we are moving towards is memory. Okay, so the third important part in your AI agent is the memory. Okay, please try to understand your models, okay, your LLMs are stateless, which means they forget everything between the calls. They forget everything between the calls. They have no memory. Okay, their memory is just existing for that particular execution. My AI agent literally cannot remember what it did 30 seconds ago, right? So memory is not something the model has, it is something that you build around that particular model. Okay, it is something that you build around your particular model, or in this case your AI agent. Okay, so typically when I'm talking about memory, or let me be specific, agent memory, we are typically looking at two parts. We are looking at short term memory and we are looking at long term memory. Okay, so you can think of short-term memory as the working record of the current job, right? So let's say if your risk analyst asked as to which funds we have checked so far, what we have found, this is what stops the agent from checking the fund 4 times. Okay, so this is the current job, the working record of the current job that you're working on. Okay, and when it comes to long-term memory is what survives after the job ends. For example, if the risk analyst always wants exposure report, like exposure of your mutual fund reported as a percentage of the net assets rather than the rupee value, that's worth keeping, right? So next week nobody has to say anything again. Okay, that is in simple terms what is short-term memory and long-term memory. Guys, if you as of now are confused between short-term memory, long-term memory, don't worry. In the upcoming session we are going to focus on agentic memory, and we are going to look into short-term memory and long-term memory. So absolutely don't worry anything about it. Okay, you can also go literally by the name. Short term, something that is going to stay for the short period of time. Long term, something that gets preserved for the long term. Okay, so this is typically where memory comes in. Okay, the fourth part. Okay, let us look at the anatomy of an AI agent again. We have done model, we have done tools, we have done memory, and now we'll look into the control loop. Okay, now when it comes to control loop, okay, here you just get a hang of what control loop is. Okay, don't worry about it. Okay, see, let me write it here. Control loop. My model decides what it wants to do, right? But somebody has to actually run that decision, feed the result back, and ask the model again. Somebody has to decide when the job is finished. Somebody has to handle the moment when my mutual funds database times out. And somebody has to notice when the agent has checked the same fund 6 times in a row and is going nowhere. Someone has to control it, right? Someone has to control it. And that controlling of an AI agent happens via control loop, my friends. Okay, so control loop is nothing but orchestration around my model. Orchestration around the model is called as control loop. Okay, and this is precisely what LangGraph gives you. In our course, we are going to use LangGraph. So when people say that LangGraph is an agentic framework, this is what they actually mean. Okay, it's a machinery that runs the loop. Let me repeat once again. What is LangGraph? It's a machinery that runs the control loop for my agent. As simple as that. Okay, but apart from just controlling the loop, it also tracks something called as the state. It also tracks something called as routes between the steps, retries, what fails and what stops. Where we have a dedicated session on basics of LangGraph, where we try to understand LangGraph basics to advance. At that point in time, all of these things will get covered. Don't worry at all. Okay, yes. Sorry for that. So my model provides the intelligence. Please try to understand. My model provides the intelligence, but control loop provides the reliability. Let me write it here. Model which is my LLM in this case, provides intelligence, but my control loop, in this case it can be lang graph, it provides me what? It provides me reliability, and reliability is extremely important in your agentic AI system. Okay, so we have understood model, we have understood tools, we have understood memory, we have understood control loop, and the last one is the environment, okay, which is the world the agent operates in. Okay, and this is everything the agent can see or affect. Okay, so when I say environment, what does it mean? It is basically everything my agent can see or affect. In this case, it can be my holdings database, the news sources that it is reaching out to, the person that it reports to, etc., etc. Okay, when it comes to the environment of that particular agent, it sets the ceiling. Okay, our agent cannot analyze a fund whose data it cannot reach. As simple as that, right? No amount of clever reasoning fixes the missing access. As simple as that. Okay, second, okay, this is the one to take seriously. Okay, an agent that can only read is fairly a safe thing, right? An agent that can send emails to the clients or let's say write to production database is completely a different risk. Yes, two important things. If I'm thinking of an agent, and an agent that only reads, that's all, it only performs reading activity, try to understand this is very safe, right? There is no risk. But just imagine about an agent which can actually write to my production database. Now just imagine, this is risky, right? This is absolutely not safe. My agent that can write to my production data, right? So this is designing the environment. Okay, and when we design the systems, agentic AI systems later in our course, one of the first questions we'll always ask is, what can this thing actually touch, or what is the thing that it can actually access? And hence defining the environment also becomes a very important part. Okay, so 5 things that are important in the anatomy of an AI agent. Okay, you see, these are the things you don't have to learn. Okay, just get a hang of what these things are. So typically, as I said, if you're working on one agent or 10 agent or an agentic AI system with a dozen of services, doesn't matter. Broadly, your agents will be made up of these 5 things only, which is the LLM, the tools, the memory integration, the control loop or the orchestration, and the environment that it is going to work in. As simple as that. So my friends, that is a simple idea about anatomy of AI agents. Okay. All right. So I hope you liked this video and you understood what is the anatomy of an AI agent. Okay. When you're interviewing, your interviewers can definitely ask you this particular question. Okay. Thank you. Let's proceed to the next video.